Welcome back to the channel. In the previous lesson, I think the previous video, we learned about variables, we learned about data types, we learned how to take input from the user, we equally learned how to display output, and we learned how to include comments in our code. Now in this video, we're going to talk about something very important: operators in C. Operators will allow us to perform calculations and make decisions in our program. So let's dive in to see what operators are. What are operators? Operators are symbols that are used to perform operations on variables and values. Take for instance, we have 5 plus 6. 5 and 6 are the values, and the operator here is the plus. So what this means is that we take the value 5 and we add to the value 6. We have other operators that we can equally use, but you see, in C, operators are divided into categories. The first category I would like to talk about is the arithmetic operators. The first category of operators is the arithmetic operators, and here we have 5 main operators that are being used under the arithmetic operators. They are the addition operator, which is represented by the plus sign, as you can see. We have the subtraction operator, represented by the minus sign. We have the multiplication operator, actually represented by an asterisk. We have the division operator by forward slash, and lastly we have the modulus or remainder, represented by the percentage sign. So let's take an example and see how we can use these operators. So we're going to declare two variables here. We'll declare int a, we assign a value to it 10, and let's declare another one b, and we assign a value to it, say 3. Now let's write a simple code that evaluates all of the operators I mentioned above. So first we do printf. I'll just do the addition here. For addition, I want us to add percentage %d. Remember, we are adding two integers. So when you add two integers, the result you get will equally be an integer. That's why I'm using percentage %d. So we \n, and then here let's take a plus b. Sorry, it's supposed to be plus a plus b semicolon. Alright, I'll just copy this and paste, and then I change the different operators. So Control C, and I'll just paste here. Control V. Let me align the code. Okay. Control V. Control V. Control V. For the different 5 operators. So we'll just change this to subtraction. We'll change this to subtraction, and we'll change the sign here to minus. We change this to multiplication. We change this to multiplication, and then we change this to the multiplication sign, asterisk. And then let's change this to division, and then we change this to a forward slash, which is a division sign, and then let's change this to remainder, and then we put the percent sign here. Okay, now the code is ready. Let me explain what happens here before we proceed to compile the code. So we have two variables, a and b. The value of a is 10, the value of b is 3. So on line 8, on the printf line, on line 8, we have addition. So what it does is that it takes the value of a and adds to the value of b. So we expect to see 13 as the answer. For line 19, which is subtraction, it takes the value of a minus the value of b. So we expect to see 7 as a result. For multiplication, it takes a and multiplies it by b. So we expect to see 70. For division, we expect to see, we cannot use a percentage. Anyway, for division, it's going to give us a whole number. Why? Because we have used percentage d here. But normally the answer is supposed to be 3 point something recurring. Now for the remainder, if you divide 10 by 3, what you get is 2, remainder 1. Therefore, what you have as answer for line 12 is supposed to be 1 and not, sorry, it's supposed to be 3, remainder 1. So what we'll get as answer for line 12 will be 1. So what line 12 does is that it returns the remainder of a division and not the answer, or not the quotient. So let's go ahead and compile the code and see. As you can see, we have 0 errors and 0 warnings. So let's run. Okay, look here. We have addition 13, subtraction 7, multiplication 30, division 3, and remainder 1. Now, who can tell us why? Normally, if we divide 10 by 3, the answer is supposed to be, if we divide 10 by 3, we should have 3.333 recurring. So why is it that our console is printing out 3 instead of 3.333 recurring? Please, if you know the answer, type it in the comment section. Now that we have seen how to use arithmetic operators, let us go ahead to talk about other types of operators. The next type I want to talk will be relational operators. And with relational operators, we use to compare values. We call them comparison operators or relational operators. We use them to compare values. What are the various relational operators? The first one is the double equal to. The double equal to. This one actually means equal to. So in C, an equal to sign is a double equal to, whereas a single equal to sign means an assignment operator. The next one, how do we indicate not equal to in C? In C, we use the exclamation mark and the equal to sign. What this means is not equal to. Not equal to. And then the next comparison operator we have is the greater than sign. This is how we do it. You just type the greater than sign, and this one is greater than. The next operator that we have is a less than sign. Less than, and this is a less than sign. The next one is the greater than or equal to. So this is how we write the greater than or equal to in C. You put the greater than sign followed by the equal to sign. The next sign is the less than or equal to. So you put the less than sign followed by the equal to sign. So these are the 6 main basic comparison operators or relational operators. So these are operators that are used to compare values. So let's get ahead to use these operators, or let's use an example to explain these operators. So we have two values here, and we use two variables. So int a, we assign the value to it 5, and b, let's assign the value to it, say 10. Now we're going to do a printf statement, and then we try to use any of the operators to show how they actually work. So printf %d \n, comma, a equal to b, semicolon. So what do you expect to see as a result? Please, if you know the answer, pause this video and comment down in the comment what you expect the result of this code to be. Now let me write another one. I'll just copy this, paste, and modify. So let's use less than. Okay, now what this does is that it takes the value of a and checks if that value is equal to b. Remember, a double equal to means equal to. So it takes the value of a, compares it to the value of b, and see if they are the same. And if they are the same, it's going to print 1 for true, and it's going to print 0 for false. So let's compile, and then we see the result. If we run, you'll see that it prints out 0 and 1. How true is this? A is 5, B is 10. And if you look here, 5 is not equal to 10. That is to say, A is not equal to B. Therefore, it prints out 0, which stands for false. So I'll just write a comment here that for a forward slash, using the forward slash, single line comment, 0 means false. And in that output, we saw that we had 1, which means true. Let's see, A is less than B. A is actually 5, B is actually 10, and 5 is less than 10. Therefore, it prints true, which is 1. So 1 means true. So 1 means true. You can go ahead to try the other operators like I've just shown you, and then I think at the end of this video we'll do a project. Now let's go to the next type of operators. The next type of operators I want to talk about are the logical operators. Logical operators are simply used to combine conditions. For instance, we can use the logical operators we have are and, not, or. So these are the three logical operators. And how do we write the and? Remember, for the and logic, both conditions must be true. So for the output to be true, the two conditions must be true. So in C, we represent and using two ampersand signs. The next logical operator that we have is the OR. And the OR operator, with the OR operator, one of the conditions, the output is true if one of the conditions are true. So in C, we represent the OR operator by two strokes like that. Then lastly, the NOT operator. We already know from basic logic gates that NOT means the opposite of the input. And so the NOT operator is represented by an exclamation mark. So let's see how we can use any of these operators. I'll start with the AND. So in order for us to test this, let's just declare int h, and let's say it's 20. Now we write a printf statement to test that. Printf, we open, let's print, %d \n. So we say h greater than 18 and h less than 30. So what this code actually does is that it takes the h, compares it if that h is between 18 and 30. So if the h is greater than 18 but less than 30, it's going to return 1, which means true. Else is going to return 0, which means false. So let's go ahead to compile the code and test. Okay, we have no errors. As you can see, it returns 1. The h is 20, so it returns true because 20 is between 18 and 30. Now, let's try again. Let's try with the OR operator, but this time around I will change. Let's put it this way: if the h is less than 18 or less than 30 or greater than 30, is going to return false because 20 is not less than 18 and 20 is not greater than 30. So let's try this and see. Remember, in the OR condition, one of the condition has to be true for the output to be true. For the AND condition, both conditions must be true. So in this case, the first condition, which is less than 18, is actually false because 20 is not less than 18. Here the second condition is greater than 30, which is still false because 20 is not greater than 30. So let's compile and see. You see we have 0 because all the conditions are false. If we do it in such a way that one of these conditions are true, let's say h is greater than 18 or h is less than 30. If we compile, the result is true, 1, because one of the conditions are true. Now, we have already seen how to use that. Now let's go to the next type of operator. The next type of operator we want to talk about is the assignment operator. The assignment operator. And the assignment operator is simply the equal to sign. Remember, I told you that if you are using double equal to, it is actually the mathematical equal to. But when you are assigning a value, you use the assignment operator. For instance, I have a variable called x. So let's declare int x. And I want to assign a value, say 10 to x. So I'll just use 1 equal to, and I say 10. So the value of x is 10. This operator is the assignment operator. Now, there are actually shortcuts to programming. For instance, let's say I want to look at this expression. We say x is equal to x plus, let's say x is equal to x plus, say 5. So what this does is that it's saying that the new value of x should be the first value of x plus 5. So the new value of x becomes 15. But there is a short way of doing this. Instead of writing this in programming, we can write it as such. We can say that x plus equal to 5. So these two things, this one, x is equal to x plus 5 and x plus is equal to 5, they are the same thing. So most of the times if you see this in code, just know that it's referring to this. So let's go on and try with an example. So let's say that x is equals to 10, and then let's use this one, x plus is equals to 5, semicolon. Now let us print the value of x and see if it's going to give us 15. Sorry, printf. We have percentage %d, and now let's call out our x. So let's compile and run. We should have 15. So the result is 15. Okay, now the next type of operator I want to talk about is the increment operator. What does the increment operator do? The increment operator actually adds 1 to the value of x. So I can say, and how do we write the increment operator? We put x. Remember our variable is x, so we can just put x plus plus. So what this does is that it adds 1 to the value of x. If we go ahead and print this out, you're going to see the result will be 6. Now, if the plus plus is placed after the x, it is called post incrementing, and if it is placed before the x, um it is called pre-incrementing. So you increment first before the value. So, but it doesn't matter, it gives the same result. So let's go ahead and compile this. You see the value is now 11 instead of 10. So it has added 1. And if I change this to put the plus in front, and we compile and run, you still have the same value, which is 11. And this increment operator is usually common when we are dealing with loops. You find them very useful when we get to the repetition control structure. Now let's try the decrementing operator. So likewise, you can actually decrement by putting two minus signs, and it's going to subtract 1 either in front or behind. So if you compile this, the result will be 9 instead of 11 in the previous case. So this is a brief overview about operators. And so now let's go on ahead to build a simple calculator in C using these operators that performs 5 basic operations: addition, subtraction, division, multiplication, and modulus. So we want to test all of these operators in one program. Now, before we go into programming, let us examine how this program will work. Normally, a calculator takes the first number and then the operator followed by the second number. But we will not go into that much details now because we have not done some advanced aspects of our lesson, such as conditions. When we go to evaluating conditions now, we are going to remodify this calculator program. But for today, let's just keep it simple and easy. So we'll need two variables, a and b. Int a, let's declare them, comma b. And I would like for us to do other variables. So let's declare the sum. Let's declare the subtraction. For subtraction, let's declare a variable for multiplication. Let's call it more. Let's declare a variable for division. Let's call it div. And lastly, let's declare a variable for the remainder. Let's call it mod. Alright, now let's go ahead to write statements to get the two numbers, which are a and b. So printf, enter, sorry, it's supposed to be enter the first number, enter the first. So this code, what it actually does, this statement gets the first number from the user. So enter the first number. In this case, our number is, the first number is a. So let's write a statement to get that number from the user. So we use a scanf function to get input, and we declared sorry and we declared a as an integer, so the format specifier is %d, and so we now call the reference operator to pass the value to it, ampersand a. So I'm just going to copy this and paste, since we'll only be changing. Control C, we'll just paste it, Control V, and we will change this to A to B, and we will change this to second number. Alright, now that we have written statements to collect the two numbers, now let's implement the logic. We say that sum is equals to A plus B, semicolon. Now let's write a statement that prints the sum. Printf sum is equals to %d \n, and then we call sum. We end with a semicolon. So I will just change. Okay, let's write for subtraction. So sub is equals to A minus B, and then we write a statement to print out that. So sub is equals to, or let's use difference. Oh, let's use sub. Okay, sub is equals to %d \n, and then we just go out, we call sub, semicolon. So I'll just copy this and paste, Control V, and modify. So we'll just change this to mul, and we'll change this to the multiplication operator. Then we'll simply change this to mul again, and we change this to mul for multiplication. Now we change this to diff, we change this to the division operator, change this to diff, and we change this to diff as well. Here we change this to mode, change this to %sign, change this to mode as well, and this too. Okay, so as you can see, it does 5 basic operations on line 12 and 13 addition, 14 and 15 subtraction, 16 and 17 multiplication, 18 and 19 division, and 20 and 21 it does modulus, arithmetic, or remainder. Okay, actually this code will have an error. Who can identify the error here? Let's run the result and then you will see what the error will be. So we compile and we run. So they say we should enter the first number. Let's enter 10. Enter the second number. I enter 3. Notice something. Sum is equals to 13. Sub is 7 because sum is 13 because 3 plus 10 is 13. Subtraction is 7 because 10 minus 3 is 7. Multiplication is 30, which is correct. But division is not correct. Division is supposed to be 3.3333 recurring. Modulus is 1, which is correct. So let's try to fix this error where division is giving us 3. So in order for us to fix this error, there are two things I would like for us to note. Note here that we declared division as an integer. So what the compiler does is that whatever fraction is gotten from that division, the fraction is ignored and only the whole number part of that number is gotten. That is to say that if we have a number such as 3.3333, what the compiler does is that it throws away this fraction and takes only this whole number in front, which is 3, because we declared the variable as an integer. So in order for us to solve this problem, I would like for us to declare the diff variable as a float. So if we come here and we declare it as a float, or you can as well declare it as a double. So let's declare it as a float. We say float diff, and if we use it as a float, then therefore we have to change this as %f so that it should reflect. If we run this code, we'll still have an error. If you know what the error will be, please write the error in the comment section. So let's run it so that you see what error we're going to have. We compile again. Now we still do 10, we do 3. Notice something. It gives us 13, 7, 30, and it gives us 3.0000. It does not give us 3.333. What could be the problem? Alright, notice here that we declared A as an integer, we declared B as an integer. So what we are actually doing here on line 19, diff A equals to divide A divided by B, we're actually doing but integer division. So the compiler knows we're doing integer division, but how come we want to store the result in a float? So what we have to do here is that we have to do a type conversion on at least one of these variables. So either A or B should be a float so that we should have the correct answer here. So to solve this problem, we're just going to declare one of these as a float. So I'll just put float A divided by B. I think with this the problem will be solved. So let's compile. Let's enter 10 as our test value again. We enter 3 and boom, the problem is fixed. We now have 3.333. So thank you guys for watching this video. In our next video, we'll be working on conditions on how to do selection or the choice control structure, where I'll show you how to use the if-else statements and the switch case. Alright, so please like, share and subscribe.